Eric Evans introduces the specification pattern in the original book on domain-driven design. Although it's covered in Evans's DDD Blue Book, the specification pattern isn't listed in the book's mind map. And honestly, it doesn't get the attention it deserves. Factories are in the book's mind map, but specifications aren't, even though in my experience, they play a much larger role in producing a clean domain model design.
In the book, Evans says that specifications mesh smoothly with the repositories, which are the building block mechanisms for providing query access to domain objects and encapsulating the interface to the database. It's this powerful combination of specification and repository patterns that truly result in a clean, extensible, and testable design. Let's dig a little more into the specification pattern and how it integrates with repositories before we show you how we've implemented it in the front desk application.
Specifications are used to specify the state of an object, and as such are primarily used in three ways: validation, selection and querying, and creation for a specific purpose. In our app, we're primarily leveraging specifications in our queries. Create explicit predicate-like value objects for specialized purposes. A specification is a predicate that determines if an object satisfies some criteria, according to Eric Evans. The most basic specification simply provides a method, typically named isSatisfiedBy, which accepts some object and returns a Boolean. These methods perform their logic in memory, and unfortunately, in remote data querying scenarios, this approach would require every row to be transferred to the application before the specification logic could be run against it.
However, more sophisticated specifications can be used in conjunction with ORMs like Entity Framework Core to encapsulate the details of a query while still allowing EF Core to translate the query into SQL that executes on the database server. Our sample application uses such a specification in the form of a NuGet package, our Dallas.specification, which is maintained by, guess who? Steve Smith.
Recall that one of the benefits of using the repository pattern and abstraction was that it prevented query logic from being spread throughout the application. This was also the reason for not returning iQueryable from repository methods. The same logic can be applied to repositories that accept arbitrary predicates, since again that means the complexity of these predicates would need to live in the code calling the repository, which might be in the user interface, for example. Using repository interfaces that accept specifications instead of custom predicates addresses this problem very elegantly.
What about the issue we learned about earlier in this module, where generic repositories weren't suited to aggregates with custom query needs? So individually typed repository interfaces were required, and each additional custom query needed to be added to this new specific interface. Well, specifications solves that problem too. Generic methods accepting generic specifications allows for custom queries where needed for any given aggregate.
A few more benefits of specifications. They're named classes that live in your domain model. You can easily unit test them in isolation, or if necessary, integration test them with a test database. They're highly reusable. They keep persistence logic out of your domain and your user interface. They keep business logic out of your database and persistence layer. They help your entities and aggregates follow the single responsibility principle by keeping complex filtering or validation logic out of them. You can easily create your own specification interface and implementation. Feel free to look at the source for our Dallas.specification on GitHub and take just the bits you find useful. Or you can reference that package and leverage all of its features and just start adding the specifications that your domain needs. It's up to you. Either way, you will need to write the specifications themselves. These belong in your domain model. When you don't have many of them, you might just put them in a root specifications folder. However, as your model grows, if you're using aggregates, it may make sense to have each aggregate include in its own folder the specifications that go with it. This makes them easy to locate as they grow in number.
Each specification class is a value object, so it should be immutable. Generally, they do all of their work in their constructor. Any variable part of the specification should be supplied as a constructor argument, and once constructed, the specification needs to be supplied to your query implementation. You can use specifications directly with EF Core, or you can use a repository abstraction that supports them. In either case, pass the specification to the query object, and it will be used to build the query, which is then executed and results are returned. The resulting code for most queries turns into one line to create the specification and another line to execute the query by passing the specification to a repository or a DB context method. Note that our sample is built on top of a repository abstraction that's provided with our Dallas specification package, and so it's fully compatible with its specification types. We'll look at the code more in the next section.
Here's an updated mind map that I've created, which shows how specifications work with repositories to define the queries for aggregates and entities. If you've been using repositories without specifications and have experienced any of the pain points we've described in this module, try refactoring to use specifications, and I'll bet you'll be surprised what a positive difference it makes.